So this demonstration explains the proof of this identity that we've written down at the bottom here, that n choose k is the sum from m is k all the way up to m is equal to n of the binomial coefficient m minus 1 choose k minus 1. And we're going to be looking at this in the case where our n is 8 and our m is 4. Okay, so on the left hand side we've got 8 choose 4. On the right hand side we've got a bunch of binomial coefficients. On the bottom of each binomial coefficient we have k minus 1. Now k was 4, so k minus 1 is 3. So we've got a bunch of binomial coefficients with 3 on the bottom. And on the top you've got m minus 1, so m is running from k up to n, so m minus 1 is running from k minus 1 up to n minus 1. K minus 1 is 3, and n minus 1 is 7. So we've got all these binomial coefficients with a 3 on the bottom and a 3 up to 7 on the top. Okay. So on the left hand side, of course, 8 choose 4, that's the number of subsets of size 4 in the set 1 up to 8. And the idea is that we're going to break these up into 5 different groups of sizes 3 choose 3, 4 choose 3, up to 7 choose 3. And the way we do this is just by splitting everything up according to what's the maximum element in your set. Okay. So over here, I mean, here's a bunch of sets of size 4 in 1 up to 8, and all these ones, the last element is 8. And then in all these ones here, the last element is 7. These elements, these sets here, the last element is 6. Here the last element's 5. Here the last element's 4. Notice the last element has to be at least 4, because if it was less than 4, then you wouldn't have space to have 4 elements in the set. Okay, so how big are these groups, right? Well, this last group here, you've got an 8, and then you've got 3 more elements. And because 8's the last element, the previous elements, the other 3 elements, they have to be in the range 1 up to 7. Okay, so the number of possibilities here, we have the 8, and then we've got 3 elements chosen from 1 up to 7. So there's 7 choose 3 possibilities, which corresponds to this term here. Then in this group here, these are all the ones where the last element is 7. And then you've got 3 more elements, and they have to be in the range of 1 up to 6. You can't have the 7 or the 8, because you've got 7 already, and 7's supposed to be the largest element, so you can't have an 8. So you've got 3 elements taken from 1 up to 6. So the number of possibilities for that is going to be 6 choose 3. That corresponds to this term here. And here, the last element is 6. 3 more elements from 1 up to 5, so there's 5 choose 3 possibilities for that. That's this term here. And then here, the last element is 5. 3 more numbers that have to come from the range 1 up to 4. So there's 4 choose 3 ways to do that, and that's this term here. And finally, the last element could be 4, and then you have to have 3 elements taken from 1 up to 3. There's only one way to do that. 3 choose 3 is one way to do that, so that's this first term here. So we've got 8 choose 4 sets altogether, split into groups of size 3 choose 3, 4 choose 3, 5 choose 3, 6 choose 3, and 7 choose 3. So we see that 8 choose 4 is equal to the sum of these terms.